This is Algebra 1, Lesson 15, Practice Problem C, the surface area of a right circular cylinder. A right circular cylinder has a radius of 20 centimeters and a length of 200 centimeters, as shown. Find the surface area of the right circular cylinder. So I've got it labeled for us here, and we've got our diagram, and we know we can do, it's going to basically be two bases, the area of the two bases, okay, and then we're going to add to it the lateral surface area. Okay, that's just kind of our battle plan here. So let's find the area of one base, and then we're going to double it. So I'll just go ahead and say double what we find the area of the one base is. So one base is going to be pi times the radius squared, right? So we'll have pi times the radius squared. So that's our idea here, where we're going to go. We know that our pi is 3.14. That's the what we're going to use to approximate it. And we know that our radius is 20. So I'm going to go ahead and put that in some internal parentheses. And I could have used some brackets here to make that clearer. So let's do that. So that is pi, 3.14, times the radius, which is 20, squared. And then we're doubling it because we have two of those bases. That's where all of those numbers are coming from. Okay? And you can do that computation. What you'll do is square the 20 and get that number, multiply it by 3.14, get that number, and then double it. Let's do that now. Okay, when you multiply those together, you get 2,512, and that is area, and we are dealing with centimeters, so that is going to be centimeters squared. Now, I was looking at the solutions manual, and it gives you two different answers. It gives you one in terms of pi, where they didn't approximate pi, and then a final answer where they did use the 3.14 as an approximation for pi. So don't let that confuse you. Two different ways of listing the answer. Now we're going to need to add to this the lateral surface area. And again, we can imagine if you cut the top and the bottom off, okay, if you cut this off, cut this here, and unroll it, then you're going to end up with this rectangle. And the top of this rectangle, this would need to be a little longer, but that's okay, would need to match up with this distance, would have to match up with this. Okay? So we would say that that pink is the circumference, and that's pi times the diameter. And for here, the diameter would be 40. So this would be 40 pi. That would be this distance here. And then you would have that times your 200. So this is going to be 40 pi. And if you do 40 times 3.14, that's 125.6. Okay, so that's that pink distance that wraps around the circle. That's the circumference. Once we get that number, we can then multiply it by 200, and that would give us this area. I'm going to color that a different color. That would give us this area because that's a rectangle. So let's do 125.6 times 200. And when I multiply those two, I get 25,120. And that's in square centimeters as well. So I have the area of the two bases, and that's what I found here. And I needed to add to it the lateral surface area. Now I want you to notice that in your solutions manual, it's going to say the perimeter of the base. They're using that, and then that's times the length. I'll just use a cursive L there. So that's where they got the perimeter of the base, which for us, we have a circle, right? So that's the same as circumference. That's the perimeter of the base, is your circumference of your base circle. And then we figured out what that was. That's 40 pi, or 125.6. And then we multiplied it by the length, which is the 200. So that's where they're getting that. And so we need to add to that what we just found out, 25,120 square centimeters. When you add these two together, you get 27,632. 27,632, and that's in square centimeters. And that would be everything you would need to cover here and here and the bottom. That would be your total surface area.